All right, so today it's just like getting used to this process because it feels weird or feels different. But trust me, it's way better than having to set up long division every time, especially when you get into longer polynomials. So our main goal today is just to get used to that process. Synthetic division, what is it like? I'm just gonna give you, I have another type of problem, but I want to do another one like that. Just grab my book ski so I can get another nice one. All right, so let's look at another one. Just once again, getting used to the steps, and I'll maybe give you guys one to try for some of you. Just try to find some nice numbers so I don't throw the bad ones at you. All right, so synthetic division. I'm too lazy to rewrite all of this, so we'll just do that. Okay, so let's do x cubed minus 7x squared minus 7x plus 20, and we want to divide that by x plus 4. All right, just going to grab a calculator if you need it. And the main thing here is the setup. So I draw my little batter's box. I don't think that's the technical term, but that's what my teacher told me when I was in high school. So there you go. So once again, you're thinking, what am I dividing by? It's always going to be a linear factor like x plus or x minus something. But when I think about what I'm dividing by x plus 4, you put the 0 of that, so you put negative 4. Then you just take the coefficients from what we're dividing. So I would put a 1, negative 7, and a 20. Okay, do a little spacing so you can see that they're different numbers. Then I just draw that kind of equal sign so we can see what we're doing here. So it's the same process, right? We're just changing numbers. So the first thing you do, you just need to bring down the first coefficient there because you need something to start with. And then you kind of just keep doing that zigzag. So you take what's in your batter's box, you zigzag down, multiply that, and then put the answer here. Add those together. That gives me negative 11. And then just keep repeating that step. Take what's here, zig down, zag up. That will give me 44. I'm too lazy. Negative 7 plus 4. I should do that in my head, 37. And last but not least, negative 4 times 37. So this is where I'm really getting lazy. I don't want to do that in my head. Negative 4 times 37 is negative 148. And when I add those, I get negative 128. Remember, that's not your answer. That's just the coefficients of your answer. So to write your answer, since this is x cubed, we subtract 1 from the degree. And this would be x squared minus 11x. I'm going to put a plus just to separate those two, 37. And your last number is your remainder. And that would be your final step. So once you get used to this, it is quicker than long division for sure. We're going to see some that are a little longer even later. We have all sorts of fun theorems that relate to synthetic division, so we'll talk about those. But we obviously want to just get used to the process first. As of right now, are there any questions? Okay. So I'm going to just say, like, the next one, can you see if you can follow the ones that we just did and try this one? So is there any part messy? Yeah. I don't know. Anything you see that's There you go. Let me find some nice numbers for you guys. Shoulder hurts. Sorry, I'm trying to find a specific. Okay, that one's beautiful. So we're going to do 3x cubed plus 17x squared plus 21x minus 9. And I want to divide it by x plus 3. So I says, hey, we've got a few, The second one kind of looked the same as the first one, we just changed the numbers up. So would you be able to follow those steps and use synthetic division to divide those two things? Two.
I have a question.
Yeah, go ahead.
For the math packet, there was like two of the problems back in like the 30s, like I didn't really know how to solve. So like later, could we look at it? Or like tell me what the answer was?
Yeah. Yeah, I'll find it and we can all look at it. Where's my math packet? Where's my packet? Let's organize my papers here. I'll find it in a few minutes. No, I'm just gonna 3 more seconds. All right, so let's look a little. So as I, just knowing the setup, so here I'm gonna put -3, I'll put the 0 as my linear factor. And then here I'm gonna put the coefficients, which are 3, 17, 21, -9. So keep all signs with their numbers there. And then we'll just do our thing. Down is 3, zigzag is -9. When I add those, I'll get 8. Sorry, I'm like a step ahead of my brain there. 8. Multiply, so zigzag that up, that's -24. Add those, it's -3. Zigzag is 9. Add those is 0. So let's see what we got. That was a cubic. We take 1 less, we take 1 off the degree. So that would be 3x squared plus 8x minus 3 with a remainder of 0. What a delight. And then just as a reminder, if something has a remainder of 0, that means it is a factor. So -3 would be a factor of that nice little polynomial there. We'll do some other stuff with that later, but just to remind you. Right now, does anyone have a question with this process? Yes.
Do we have to write it?
No, I mean, yeah. So if you see it's 0 and you just don't write it, that's also fine. Because we assume if nobody's there, it's 0. Any other questions? Anyone at home? Anything in general? Okay, so the rest of the stuff, we're doing synthetic division every time. It's just some of the problems have different directions and just like different wording. We're gonna talk about something called remainder theorem. And just the way it's set up, but it's all synthetic division. But I just wanna make sure you see how some different problems are set up. And then we'll see, we just all comes back to doing that fun stuff. All right, let me just write this. Okay, so we're gonna say evaluating a polynomial. Ooh, that sounds fun. But we're gonna use synthetic division to do it, so that's the magical part. So given p of x, so it's a function. We use p because it's a polynomial, so nothing too crazy. So basically, we're gonna be given a polynomial, x to the 5th minus 2x cubed minus x squared plus 2. And that's gonna ask, what is p of 3? As of right now, you're like, wait, what? What's happening? Like, how does this even relate to synthetic division? Doesn't that just mean I plug 3 in? Technically you could, but we're not doing that. So when we eventually do a problem like this, it will say use synthetic division to figure this out. So just as a heads up, this is called remainder theorem. So let me kind of just write it out for you first, and then we'll go back and do it. So remainder theorem is just asking for this specific question. When I say P of 3, this is killing me. P of 3 is the remainder. I could write today, remainder. When you divide P of X by 3. So this is literally what we do when you see a problem like this. So I'll just show you. Excuse me, I'll say it by X minus 3. Once you see it, you'll be like, oh, really? That's all it is. It's not bad. It's just sometimes we kind of switch up how things are set up, but we're really doing the same thing. So that's kind of the instance here. So this is what happens if you see something like this. P of X is just your polynomial. P of 3 is saying we're basically going to divide by 3, and then our answer is what the remainder is. So here's how we would set it up. Batter's box. If I say P of 3, then we put a 3 there. We don't have to change the sign. God bless you. You only change the sign if it gives you like X minus 3X plus 3. We take the coefficients, be careful on this one. The reason being is it starts with X to the 5th. The coefficient's 1. There is no X to the 4th. You have to put a 0. There's an X to the 3rd. There's an X squared. Oh, am I running out of no? This is good. There is no X. There's a constant. So if you need to rewrite this, please do so. But don't forget that when you skip terms, you got to throw the 0 there for them. So feel free to write it out like that just so you can see this. But okay, we're just doing what we've been doing. You can do that. Bring it down. That's 1. Then we just do our zigzag. That times that is 3. If I add these, I get 3. That times that is 9. If I add those, I get 7. I kind of like it. I feel like it's like soothing to me just doing this over and over. I don't know why. That times that is 21. Add them, I get 20. That times that is 120. Whatever works. And then 1 is 360. Yeah. Wait, did I do something? No, what did I just do wrong?
Yeah, it's not. It's
Yeah,
23 times
It's
20.
60. What did I just do in my head? I don't know what I was doing. I'm sorry. 3 times 20 is 60, not 120. I knew I did something wrong. Don't know where the brain went on that one. I was looking at something else. Okay, so that's 60. And then that's 180, and that's 182. Okay. Whew. Now, all I actually care about for this problem is what the remainder is. So as much as I'm loving all that other stuff, this is what I'm focusing on, the remainder part. And here's how you write your answer. P of 3 equals whatever the remainder is. And you're done. So remainder theorem, you're probably saying, why the heck do I even care about that? If you actually took 3 and plugged it into that function, it's gonna be 182. So I could just take 3 and plug it in, but that would be too easy, guys. We're gonna make things complicated here. If I took 3 and plugged it in for X here, and you can do it right now if you want in your calculator, it will come out to 182. But if you're ever bored and you don't want to do that, you can just do synthetic division and then find the remainder. Why wouldn't you do that, right?
Wait, so let's say you were too confused to do synthetic.
Oh no, it will say use synthetic division.
Oh.
Yeah.
You could just put it in.
No, you can't just put it in. Come on.
Can I check your answer that way?
Yeah, you can check me out. Fun stuff. So that one, it was just a synthetic division problem. It wasn't anything too fancy. It was just given that information, how do we set it up? Once again, we're taking our coefficients from P of X. We're dividing by 3 because it's asking with the polynomial, the 0 is 3. It just happened. And then you just do your synthetic division like normal, but you're looking for the remainder, so just as a heads up. All right, let's do one more of those. And there's one other problem I wanted to show you, and then we might just pack it in for today. Don't want to work our brains too much today. And then I feel like I do too much in this class, and then I have it next period too. But it's always 10 minutes less, and I always get thrown off. So.
I know, last period doesn't really count.
Oh my God, it's the worst. So sometimes I need to like make myself go slower here so that they get the same amount of information there. All right, so we have P of X, that's our polynomial. And I'm gonna say use synthetic division, right? I'm gonna give you the division to find P of -4. All right, so once again, we know we're doing synthetic division, it's just making sure that we can set it up correctly. So I'm gonna help you with the setup, you guys are gonna do the division part. Batter's box, we just put -4, so that is the 0, right? We use our coefficients, please make sure we're good. I think we have nope, we don't have a squared, so we remember that 0. So I just go down, okay, 5, 4, 3. There is no squared, so I put it in 0. We have our linear, and we have our good old constant. So can you guys take the next moment or two and figure out what is P of -4 by using synthetic division? Where's the type of problem I want to do? Not there. I'll do one more problem after this. I just want to show you. I don't have my big numbers.
Alright, so literally this, again, the choose one variable that the explanatory one is the response, we think what the standard one looks like. So heights in inches, heights in centimeters, which one's going to explain the other? Or does it not really matter?
Actually said study twice.
I don't think it really matters. So x by y, regardless of which one I choose by x by y, I'm going to get a perfect relationship, right? Because you take your height, you multiply by 2.5 fours, and then it's your centimeters. So no variability here. You're going to have a perfect, positive or linear strength is going to be perfect.
I'm gonna do one more problem. I just want to make sure my numbers are correct. I don't want to confuse you. Or I don't want to confuse myself. And I need to divide them.
Yes. Yes.
Those will be delightful numbers. So, okay, I just, let's get going here. Down, that's 1. Zigzag is -4 is -7. That times that is 28, so that's 0. Ooh, fancy. That times that is 0, so that's 0. That times that is 0, so that's 5. That times that is negative 20, so that's 0. So I would say that P of negative 4 is 0. And if the remainder is 0, then that means negative 4 is a factor. Oh my God, you guys, pay attention to me. Oh no, we still have one more problem. We still have one more. Okay, I know you're excited. I am too. We still have one more problem. So it's kind of taking this idea, like if we find the remainder 0, it's a factor. The next one, I'm going to tell you one of the factors, and then we're going to find the rest of them. This is going to be fun. All right, so I'm going to say, we'll reset in a second, that P of x is x cubed minus 19x minus 30. Actually, I'm just gonna, it doesn't really matter. I'm going to tell you that P of negative 2 equals 0. If P of negative 2 equals 0, what are the other factors? Okay, so what the heck does that mean? Let me erase over here. This will be our last problem. We're given a nice little polynomial. Now, what does this mean? If P of negative 2 equals 0, what does that mean? If I set this up and I said equals 0, that was our answer for the last one. It meant that the
Y equals 0. It's a factor.
that the remainder was 0. So what does that mean about negative 2? That it's a factor. Okay, so ready? We're just like, it's just reasoning, because once again, it's all stuff we know, it's just like the way it's written is weird. This is saying that negative 2 is a factor of P of x. AKA, when we divide it out, we're just going to get a remainder of 0. So what we're going to do is actually divide it out. I know the remainder is going to be 0, which is exciting, but then I'll show you how to find the other factors, because I know negative 2 is one of them. So I'm going to take negative 2, and I'm going to divide it by my coefficients. 1. There's no x squared term, so I'm going to put a 0. Negative 19, negative 30. Okay. That's good. I know going into it, the remainder should be 0, but we're going to kind of see what we get. Bring this down. We're getting used to our steps now. Do our little zigzag. Every time I'm adding, that will give me 4. That would give me negative 15. That would give me 30. That would give me 0, which I knew was going to happen. I knew the remainder was 0. That's exciting stuff. So let's see what we're left with. We have a bunch of coefficients. If that was x cubed, I take 1 less than that. So that's x squared minus 2x minus 15. Once again, remainder 0. I don't really care about it anyway. So if I said, what are the other factors? How would I find that if I have a quadratic, everyone?
Factor.
Yeah, just everything goes back to factoring, right? Good old factoring. So you can find the other zeros now. I wouldn't have been able to find them originally had I not told you that original factor. So that's why I told it to you. Because when you divide it, you get it to a place that you can now actually solve. And then let's see what we get. That'll be minus 5 plus 3. So my other factors are x equals 5 and x equals negative 3.
Along with
negative 2. So yeah, if it said list all the factors, you would throw the negative 2 in there. But I just said the other factors. So we'll do more of that on Thursday. Thursday's kind of like, let's bring everything together day. Have fun, you know. But hopefully the synthetic division process isn't terrible. I kind of like it. And we've seen like most of the problems are just synthetic division. It's just sometimes, you know, the way it's worded, we just want to make sure we understand what is being given to us and what we're looking for and all that fun stuff. So we'll do more practice as we go. I'm going to pause that bad boy.